Alright, for this lesson we're going to take a look at the surface area and volume of prisms and cylinders. So in geometry, a prism is a three-dimensional object which has two bases or ends that have the same size and shape and are parallel to one another, and each of whose sides is a parallelogram. In this course, we focus on right prisms. A specific category of prisms. A right prism is a prism whose sides are going to be rectangles. The top and the bottom, so the bases, aren't necessarily rectangles, but the other sides will be rectangles. The following diagrams illustrate types of right prisms which are studied in this lesson. The bases or ends of the prisms are at the top and the bottom of each diagram. So we have the triangular prisms, where we're going to have a triangle on the top and the bottom, and then three rectangles that make up the other sides. We have a right rectangular prism, where we have a rectangle on the top and the bottom, and then four other rectangles. And then we have a cube, which we all know is just a square on the top and the bottom, and then four other squares that are the same size going around the sides. Our formulas are the volume is just going to be what the area of the base is multiplied by the height. So if I can solve for what the area of the base is, I'm just going to multiply it by whatever the vertical height is. Same thing here. The area of this base on the bottom multiplied by what this height is. Or if it's a cube, the area of the base multiplied by the height, which is the same as the side lengths on the base. So that one I can actually just do cubed. The surface area, which is what people struggle with a little bit more, is figuring out all of the different faces on the prisms and then adding up the area of all of those. There's some formulas which you should know, but they are at the back of your book if you need to reference them. For example, a circle, if I'm looking for the circumference, I can either get it by pi times the diameter or 2 pi r. When we're looking at areas, well, a rectangle is just multiplying the two dimensions. A square is one side length multiplied by itself, or one side length squared. A parallelogram is you need to create a vertical height that is perpendicular to the base and multiply them. So then it's going to look like I cut off this section and moved it over here, and it just looks like a rectangle. A triangle is 1/2 of the base times the height. A circle is pi r squared, and a trapezoid is 1/2 times the height times the length on the top plus the length on the bottom. So, for example, what? If I'm going to determine the area of the base of this prism, well, let's use the shape that we can see on the top, because the top and the bottom are going to be identical, and I have a triangle here. And for this triangle, I know what the base is here, that's 10. The problem is I don't know what the height is. But I can see that there's a smaller right triangle that exists in here, and I do know the hypotenuse of this is 13. So if I pull this shape out, then for this right triangle, I have, this is going to be 13, this is going to be half of the base length, which is going to be 5, and I can solve for the missing part, which I'm going to call x. So when I'm doing this, I'm going to say that x squared is going to equal 13 squared minus 5 squared, which means that x squared is going to equal 144, where x is going to equal the square root of 144, or 12. Now, that means that the area of the base, which is a triangle, has a base length of 10 going all the way across here, and a vertical height of 12. So I can solve this by saying that the area of a triangle is going to equal 1/2 of the base times the height, or 60 centimeters squared. If I'm determining the volume, then it's the volume is equal to the area of this triangle multiplied by the height of the prism, or 60 multiplied by the vertical height of this prism is 6. 360 centimeters cubed. If I'm determining the surface area is where it gets a little bit more complex because I need to figure out what all the different faces are. Well, for the faces, I have the triangles that make up the top and the bottom. So I can say that I have two of those triangles, plus I have these rectangles that make up the side here and the side here, and those are going to be identical rectangles. And finally, I have the rectangle that exists on the bottom. I know that this one is going to be 10 with a vertical height of 12. This is 13 by 6. And this is 10 by 6. Which means, to solve this, I'm going to have 2 times 1/2 of 10 by 12 plus 2 times 13 by 6 plus 10 by 6. All of these together are going to make 120 plus 156 plus 60, or a total volume of 336 centimeters cubed. The table on this page shows the common liquids used. So if I'm doing for metrics, the solid shapes are going to be centimeters cubed, meters cubed, kilometers cubed. The liquids are going to be in liters or milliliters. If I'm doing imperial, it would be inches cubed, feet cubed, yards cubed. And the liquid is going to be in gallons and pints and ounces and yada yada yada. The biggest thing is knowing that 1 centimeter cubed is going to be the same as 1 milliliter, and 1,000 milliliters is the same as 1 liter. We also have the US gallon conversions, the imperial gallon conversions to a Canadian liter, and 1 gallon is the same as 8 pints. So, for example 2, Receptacle Inc. is a manufacturing company that makes containers of various sizes for materials such as corrugated cardboard, metal, glass, plexiglass, or plastic. Two companies ask Receptacle Inc. to produce containers of the same size in the same shape of a right rectangular prism. Cubicle Limited needs a plastic container 15 centimeters long, 10 centimeters deep, and 8 centimeters high, which to pack their 1 centimeter cube sponges. Water World Aquarium needs small glass aquariums with the same dimensions in which to keep their samurai fighting fish. So the first thing, calculate the volume of the container for Cubicle Limited. So if I have the dimensions of 15 by 10 by 8, then if I'm doing 15 by 10 by 8, I have 1,200 centimeters cubed. Is the centimeters cubed an appropriate unit to represent the volume of the container? Yes. Because the sponges are solids. The small glass aquariums for Waterworld Aquariums Inc. will be filled with water. The volume or capacity of the aquariums is given in liters or US gallons. Determine the capacity in both liters and US gallons to 2 decimal places. Well, the conversions I'd have to do, because I've already solved the volume, is if I have 1,200 centimeters cubed, that would be the same as 1,200 milliliters, because centimeters cubed and milliliters are the same. Then I could say that, well, if I had 1,200 milliliters over 1, I'm going to multiply that by 1 liter over 1,000 milliliters, or 1.2 liters. If I want to do it in US gallons, then I need to know what the conversion rate is for US gallons, and I get it right here. 1 US gallon is 3.7854 liters. So I'm going to say that the volume of 1.2 liters over 1 is going to get multiplied by 1 US gallon divided by 3.7854 liters, or 0.32 gallons. Remember, this is US gallons, not UK gallons.